Welcome to the first of my exclusive video reviews for Martin Lynch & Son Limited. It's fitting to start with the IC-7300 as this new rig also breaks new ground as the first direct sampling SDR rig to be launched by one of the big three Japanese manufacturers. Although SDR technology is commonplace, many operators have been reluctant to change to SDR for their main rig due to their total dependence on the shack computer. However, the IC-7300 breaks that link to provide a computer-free, standalone, yet powerful SDR transceiver. So let's start with an overview of the IC-7300. The IC-7300 is a compact transceiver that provides full transmit and receive coverage of all the UK amateur bands from 1.8 MHz through to 70 MHz. The output power is rated at 100 watts on all bands except 70 MHz, where it's limited to 50 watts. On the receive side, the coverage runs from 30 kHz right through to 74.8 MHz with no gaps. To round off the hardware, there's a built-in antenna tuner to make antenna matching effortless. Although the IC-7300 is a full-featured direct sampling SDR transceiver, it doesn't require the use of a computer because it's operated entirely by the front panel controls in combination with the touchscreen display. This brings the benefits of software-defined radio to everyone without having to delve into the potentially complex world of computer-based SDRs. As well as doing away with the computer, ICOM have used the manual controls and touch display very skillfully to create a sophisticated transceiver that's surprisingly easy to use. With all the essential elements included with the 7300, you just need to add a power supply and antenna and you're on the air. In this part of the review, I'll take a more detailed look at the various inputs and outputs provided on the 7300. Let's start with the power supply, where the usual 13.8 volt DC is required with a current draw of up to 21 amps when running on full power. The supplied power lead for all European versions is fitted with an additional EMC protection unit. This connects to the rig using a standard ICOM power plug along with a spade connector to ground the EMC unit. The free end of the PSU cable has bare ends ready for connection to the shack power unit. Next is the antenna, where the IC-7300 has a single SO239 socket for all bands and includes an automatic antenna tuner that can match loads with an SWR of up to 3:1. Unless you are using one of ICOM's wide range antenna systems, you'll probably need to add an antenna switch to your shopping list. The supplied microphone is ICOM's HM219 electric unit that plugs into the 8-pin connector on the front panel. This microphone has a PTT plus up and down buttons, which is all you need for basic operation. Also on the front panel was a standard 3.5mm headphone jack that muted the internal speakers when used. This was designed for headphones in the 8 to 16 ohm range, but also worked okay with my higher impedance HD480 and HD25 headphones. A welcome extra was the provision of an SD card slot on the front panel. This can handle cards of up to 32 GB capacity and is remarkably versatile. You can use the card to save memory channels, IC-7300 data settings, screenshots, audio and communications logs, to name but a few. Moving on to the rear panel, there was a 6.3mm stereo jack that was used for the Morse key and could be set to handle either straight or paddle keys. Next comes an external speaker jack that can supply 2.5 watts of audio into a 4 or 8 ohm speaker. Those using external linear amplifiers have a pair of phono sockets that provide the essential send and ALC feeds. And as you would expect, the IC-7300 has the usual ICOM 3.5mm CIV jack for CAT control using an ICOM serial cable or converter. However, new on the 7300 is the USB connector that provides both a sound card and serial port that can be used for CAT and data modes operation. This is a very welcome addition that voids the need for an external interface when operating data modes, but I'll have more on this later. For those that need to access the analog audio, the IC-7300 still provides wired access to the audio and assorted control lines via the 13-pin DIN accessory socket A nice feature here was the inclusion of a 13-pin DIN plug that was pre-wired with 10cm colour-coded tails. This is ideal for making a homebrew interface cable. The final connector on the rear panel was a custom 4-pin socket that was used to power and control ICOM's dedicated external antenna systems. In this chapter, I'll give you an insight into the construction and technical features of the 7300. As we've come to expect from ICOM, the 7300 is beautifully built with a solid die-cast aluminium chassis, providing an excellent combination of electrical screening and mechanical stability. Starting with the receive chain, the signal passes through a 76 megs roofing filter and a switchable 18 dB attenuator before application to the main filter bank. This comprises 15 switchable bandpass filters that provide good protection for strong out-of-band signals. The output from the filters passes to the analog to digital converter via a switchable preamp. The role of the ADC is simply to digitize the entire incoming RF signal. The actual ADC device is not listed in the schematics, and the physical chip has a heatsink cemented on top, so I couldn't identify it. The parallel data output from the ADC is fed to a field programmable gate array, or FPGA, for processing. The main role of the FPGA is to downsample the high-speed data from the ADC and produce more manageable slices of spectrum. In the case of the 7300, the FPGA produces two 36 kHz wide digital IF signals, one for each VFO. These signals are further processed using a Texas Instruments digital signal processor, or DSP chip. It is this chip that handles the demodulation and final filtering of the received signal. In addition to the two 36K digital IF signals, the FPGA also produces a wider bandwidth digital slice to feed the spectrum and waterfall display. To improve the ADC noise when receiving weak signals alongside strong signals, ICOM have introduced the new IP Plus feature. The workings are not fully explained in the manual, but I suspect it uses a dithering technique. The feature is only relevant when receiving weak signals and is available via the function menu. For the transmit path, the modulated signal is generated in the DSP chip and passed to the FPGA for resampling to the required frequency. The resampled transmit signal is then fed to the digital to analog converter, or DAC. The analog output from the DAC is then low-pass filtered and passed to the power amplifier via pin diode controlled drive and ALC stages. The output from the PA then feeds a bank of 7 switchable low-pass filters, followed by the power SWR bridge and the antenna socket. Frequency accuracy and stability is managed by a temperature-controlled crystal oscillator that provides an overall stability of 0.5 parts per million. In this video, I'll be taking a closer look at operating the 7300. The supplied documentation was excellent and included a printed 36-page basic manual that had everything I needed to get started. This was supplemented with a CD-ROM that contained the full manual plus 17-page set of schematic and block diagrams. All the documents were in high-quality PDF format and complete with viewing software. At the heart of operating the 7300 is the large touchscreen display. To keep operations simple, ICOM have opted for a 2-touch system that uses a short touch or a 1-second press. When combined with the on-screen soft keys, this provides access to a huge range of features without overcrowding the display or the front panel. The ICOM soft keys are simply on-screen buttons along the bottom or side of the display that change according to the mode you're using. It's not a new idea, but ICOM have implemented it very well in the 7300. Let's move on to look at the tuning options. The main tuning knob is a very nicely weighted 50mm diameter metal knob with a rubberized grip and an indent for finger spinning. Just at the bottom of the knob is a small lever that adjusts the damping, and I found the lightest setting was best for me. As with all modern rigs, the tuning knob actually drives a shaft encoder that alters the tuning in discrete steps. The 7300 automatically sets these step sizes to match the selected operating mode, and these were well chosen. However, you can use the menu system to change these defaults. The 7300 has a very neat technique for band changing and tuning step selection. To change band, I just had to touch the megahertz digit on the display to trigger the pop-up band menu. Here I could click one of the preset bands or use the direct entry button with the on-screen soft keyboard. Once on the desired band, I could use the rate-sensitive tuning knob to quickly navigate across the band. For some modes, you may need finer tuning steps, and a press of the Hertz digit switched the tuning to 1 Hertz. An alternative to using the 1 Hertz option is the quarter rate tuning that's available when using the SSB Digital, CW and RTTY modes. One of the star attractions of SDR receivers is their spectrum displays that give a graphical view of band and are a great way to spot activity. The 7300 includes a versatile spectrum and waterfall display that also allows touch tuning. ICOM have devised an ingenious two-touch tuning system that I've not seen implemented elsewhere. To tune a signal, you just touch that point on the screen and a magnified but frozen pop-up of the point you touched will appear. You can then touch again on the centre of the signal you want and the receiver will retune. The fact that the enlarged slice is frozen makes selection of the exact tuning point much easier. The other new twist here is that you tune to the centre of SSB signals. In some SDR radios you have to tune to the left-hand edge for a USB signal or the right-hand edge for a USB signal. This is always a bit of a guess because you actually have to click about 300 Hz away from the visible spectrum. This is because communications audio normally filters out frequencies below 300 Hz. So the suppressed carrier is actually spaced about 300 Hz away from the end of the visible spectrum. With the ICOM system, you always click on the centre of the signal and the software selects the correct tuning point. Of course, the display still shows the frequency of the suppressed carrier, as it should. The net result is that with a bit of practice, I was able to get much more accurate initial tuning from the touchscreen. This is particularly helpful for those new to SDRs, as it will go a long way to ensuring you get good results first time. Whilst the 7300 features 2 VFOs that can be displayed together, most operators are likely to be using a single VFO for most of the time. In this case, the spectrum and waterfall display can be set to use about 2/3 of the screen, thus making it much easier to view. The width of the spectrum on show can also be switched between a fixed band segment or a variable bandwidth around a central point. The fixed band mode was preset to show entire amateur bands, but this could be reconfigured to show smaller band segments. Details of the 7300's band segments were stored in the 30 band edge memories, thus allowing up to 15 band edges to be preset. Personally, I preferred to use the display in center mode, as this put the tuning point in the center of the screen and showed a selectable bandwidth either side. Pressing the span button toggled the display bandwidth between plus or minus 2.5 kHz and plus or minus 500 kHz in 8 steps. A useful extra here was the long press on the span button that switched the display straight to the plus or minus 2.5K setting. This was ideal for taking a close look at the tuned signal or spotting narrowband data modes activity such as PSK31. For the more advanced operator, the IC-7300 display has 4 pages of settings that can be used to customize many aspects of its performance. Closely associated with the tuning option is the IC-7300's built-in memory channels, where you can store all your favourite frequencies. The 7300 has 99 memory channels, each of which stores both the frequency and the mode information, along with a 10-character name. As a data modes operator, I use the memories to store my main data mode's activity frequencies. These could then be recalled using the up and down buttons with the rig in memory mode. To supplement the normal memory channels, the 7300 has a handy set of Memo Pads. These are temporary stores that can be used to quickly grab a frequency and mode instead of making written notes. To store the current frequency, I just had to give a 1-second press of the M-Pad button. To cycle through the stored notes, just took a short press of this button. I found this a really useful temporary store for details of a signal that I wanted to return to. The M-Pad memories use a circular store, so when the memories are full, the next entry will overwrite the oldest memory. Now let's look at the scanning options. ICOM have added some neat scanning ideas into the 7300. In addition to the usual scanning of memory channels and a scan between two frequencies, there is the F-scan option. This sets the 7300 scanning over a specified bandwidth either side of the current tuned frequency. The bandwidth can be one of 7 values from plus or minus 5 kHz to 1 MHz. This is great for those occasions when you know the rough location of a signal but need to search around to find it. Instead of swinging the dial from side to side, you can set F-scan to do it for you. Just select the bandwidth, set the squelch, and the 7300 will search out the signal. When scanning on HF, the scan will tend to stop on the edge of the signal rather than the correct tuning point. ICOM have a neat solution for this in their Find Scan option. Instead of stopping when the squelch opens, the scan continues but at a slower rate, so you can decide where to stop the scan. I thought this simple idea worked really well. In this video, I'm taking a look at the filtering and noise reduction capabilities. SDRs are renowned for their excellent filtering, and the 7300 doesn't disappoint. To keep life simple, 3 well-chosen preset bandwidths are provided for each operating mode. For example, SSB used 3 kHz, 2.3 kHz and 1.8 kHz. However, these bandwidths can be very easily changed with a long press of the FIL letters on the screen. This opens up the configuration panel where you can alter the bandwidth and toggle the filter shape between a sharp and a soft profile. You can also use the twin passband tuning controls to offset the filter shape. If you get in a muddle, just hit the def button to return all the settings to their default values. The rotary twin passband tuning controls on the front panel provide a simple way to adjust the shape and position of the current passband filter. It's a clever system that works by offsetting 2 filter profiles so that the resultant filter is created from the overlapping area. The passband tuning is available for all modes and was great for dealing with adjacent channel interference problems. The 7300 has 3 systems for dealing with noisy signals. For impulse noise, the noise blanker can be activated via the front panel button, and a long press will trigger the configuration pop-up where you can alter the level, depth and width of the blanker. Next up is the digital noise reduction that's helpful for reducing hiss. Again, the amount of noise reduction can be set with a long press of the NR button. To complete the noise tools, the 7300 has a very effective notch filter that does a great job in its default automatic mode. If necessary, you can quickly change to manual control and adjust the frequency and width of the notch using the multi-knob on the front panel. When operating data or CW, the notch filters default to manual tuning, as auto-tuning would mess with the wanted signal. To round off the receive audio chain, the 7300 includes adjustable audio filtering, so you can tailor the response to suit your personal preferences. You can have different settings for each receive mode, and the adjustments include bass and treble, plus adjustable high pass and low pass filters. Here we look at transmitting with the 7300. 7300 is equipped with all the transmitting modes you need for operating on today's amateur bands. Starting with the speech modes, the supplied HM219 electret microphone handled my voice well and was comfortable in the hand. The only thing I didn't like was the positioning of the up and down buttons on the top edge, as they were a bit awkward to reach. Voice processing options on the 7300 were excellent, with different settings available for AM, FM and SSB. For example, on SSB there were bass and treble controls, along with 3 preset bandwidths, and even these presets could be changed. Once I was happy with the frequency shaping, I could use the 7300's adjustable compressor to add a bit more punch, and a setting of 3 was about right for my voice. To help you check the quality of the transmit audio, the 7300 includes a helpful monitor facility that routes a sample of the transmit signal back through the receive chain so you can monitor via the speaker or headphones. Vox is well catered for with controls for Vox gain, anti-Vox, delay and voice delay. There's also a transmit shift feature where the transmit frequency can be offset by up to 9.99 kHz. The 7300's dual VFOs can also be used for split frequency working, and thanks to the direct sampling design of the 7300, the transmit and receive frequencies can be split across any band. So you could transmit on top band and receive on 70 megs if you really wanted to. Quick access to the transmit power level and mic gain is available at any time via a single press of the multi-dial. Let's now have a look at data modes operation with the 7300. The 7300 makes data modes operation a breeze thanks to the integrated USB sound card and serial port. As a result, you no longer need to use a data interface unit. Before I could use the USB port with my PC, I had to download the serial port driver from the ICOM support site. Once that was installed and the USB lead connected, the serial port and sound card were selectable from within my data mode software. As I'm a keen supporter of the Raspberry Pi, I also linked the 7300 to a Pi 3 loaded with the latest version of FLDigi, and was delighted to see that both the sound card and the serial port were recognised straight away. The only extra requirement was to download the 7300 XML file to support the rig cat control from within FLDigi. However, I'm sure the 7300 will be included in the main software very soon. You can also operate data modes using AFSK with a conventional external interface, as all the necessary connections were available via the 13-pin DIN accessory socket on the rear panel. Like many ICOM rigs, the IC-7300 has integrated RTTY transceive facilities. Although it has its limitations, it is possible to make simple RTTY contacts using just the 7300. CW operation is very well supported in the 7300 with a built-in electronic keyer that can handle speeds up to 48 words a minute. I like the way the pitch could be adjusted between 300 and 900 Hz to cater for different preferences, but a real gem was the auto-tune system. All I had to do was tune close to the desired signal, and a single press of the auto-tune button would trigger the IC-7300 to complete the tuning and produce the selected side tone. This was a great partner to the click tuning on the display, as I could roughly tune with the display and then hit auto-tune to finish the job. Of course, this only works when there's one signal in the passband. To further support CW operation, there were 8 keyer memories that I could use for standard messages, and one of those memories supported an incremental count for contest work. The normal CW operating mode was break-in, where the rig automatically reverted to receive at the end of each over, but the timings were fully configurable so you could easily drop back to receive between words. The 7300 also supports full break-in with a maximum speed of 45 words per minute. I'm sure the 7300 is set to become a classic, and it's certainly the first of a new breed of transceiver from this stable. ICOM have done extremely well to pack a huge range of user controls into such a compact and easy to use transceiver. The facility to save and recall settings with an SD card means you can freely customise the 7300 for contest work or other applications and then quickly revert to everyday settings. Although the 7300 is highly configurable, you don't have to go down that route, as the rig is ready to go straight out of the box. Just connect power, mic and antenna and you're in business. I've used lots of rigs over the years, and the best ones always seem to have a special quality or X factor that's instantly recognisable when you start tuning around. This often shows as a clear separation between signals and a very clean audio. The 7300 clearly has these characteristics, and its performance rivals that of other rigs at a much higher price point. Having had the opportunity to delve into the 7300, I'm not surprised they're flying off the shelves. This is a seriously good rig.